I welcome you to the today's session on test of normality using SPSS. Testing of normality. Mostly statistical procedures requires us to verify at least two assumptions, that is the normality assumptions and the assumptions of absence of outliers. And there are two methods normally we use to check the normality assumptions. That is, the first one is numerical method and second one is graphical methods. Let's talk about the various properties of normal distribution. The first one is the mean is equal to median is equal to mode. The second one is the distribution is symmetrical about the mean. That is, half the values falls below the mean and half above the mean. And moreover, the distribution can be described by two values, that is the mean and the standard deviations. Now let us talk about the empirical rules. Empirical rule, that is also known as 68, 95 and 99.7 rule, which tells us where most of the values lies in the normal distribution. First one says around 68% of the values are within one standard deviation from the means. Second one, around 95% of the values are within two standard deviation from the means. And third one is around 99.7% of the values are within three standard deviation from the means. So this is the normal distribution curve, normal distribution bell curve, and this is the kurtosis curve. In kurtosis, we have three different types of measurement, that is leptokurtic, mesokurtic, and platykurtic. So leptokurtic means when the kurtosis value is more than 0, and mesokurtic is the when the kurtosis value is 0, and platykurtic is when the kurtosis value is less than 0. So in general, the mesokurtic is considered to be the absolute normally distributed curve. Now let us talk about two methods normally we use to check normality. The first method, that is the numerical method to check normality, is skewness and kurtosis indicator, and the second one is the Shapiro-Wilk normality test. And in graphical methods, we have two different categories. First one is the histogram and the second one is the QQ plots. So a Z test is normally applied to check the normality test using skewness and kurtosis. And a Z score should be obtained by dividing the skewness value or excesses of the kurtosis by the standard errors. And here we got the formula, that is Z is equal to skewness divided by standard errors, or in case of kurtosis, Z is equal to kurtosis divided by standard errors. As the standard error gets smaller when the sample size increases, so the Z test and the null hypothesis of normal distribution tends to be easily rejected in larger samples with distributions which may not substantially differ from normality, while in small samples, null hypothesis of normality tends to be more easily accepted than necessary. So therefore, the critical values for rejecting the null hypothesis needs to be different according to the sample size, because a different sample size will show a different level of Z score. So for small sample, consider for example n less than 50. So if the absolute Z score for either skewness or kurtosis are larger than 1.96, which corresponds with the alpha level of 0.05, then we are supposed to reject the null hypothesis and concludes the distribution of the sample is non-normal. Similarly, for a medium-sized sample, that is when n ranges between 50 to 300, and in such scenario, we reject the null hypothesis at absolute Z value over 3.29, which corresponds with the alpha level of 0.05, and concludes the distribution of the sample is non-normal. And when we have a sample size greater than 300, depending on the histogram and the absolute value, the skewness and kurtosis, without considering Z value, either an absolute skew values larger than 2 or an absolute kurtosis larger than 7 may be used as a reference value for determining substantially non-normality. And lastly, the variable is normally distributed with a 99 percentage confidence level if both standard scores lies in this interval, that is minus 2.58 to 2.58. Now let's talk about the various hypotheses for the normality test. The first one is the Shapiro-Wilk test, And the null hypothesis says the variable is normally distributed, and alternate says the variable is not normally distributed. So we accept the null hypothesis if we have significant level greater than 0.05. And also we have various QQ plots for various types of distributions. So this is the QQ plot for positively skewed distribution, and this is the QQ plot for negatively skewed distribution, and the QQ plot for a leptokurtic distribution, and QQ plot for a pericardic distribution. Now next, let us consider when the normality assumption is violated. When we perform any statistical operations and we find that the normality assumption is violated, so we have different solution for that. The first solution consists of applying a transformation to the variable so that hopefully the new variable is normally distributed. And the second solution consists of running a non-parametric test if our variables are not normal. For example, the Spearman correlation or man-Whitney test. The third solution is to run the analysis regardless. That is, many parametric tests are pretty robust to deviations from normality, especially when the samples are very large. And this is a very general tendency. When the samples are very large, the parametric tests are pretty robust to deviations from normality. And also the fourth solution consists of performing a so-called sensitivity analysis. So what is sensitivity analysis? That is when we run two tests simultaneously, that is a parametric test as well as a non-parametric test simultaneously we run and try to check the normality in both the cases. So if both tests lead to the same conclusion, then we can say the normality violations are not an issue. And if the conclusions are totally different, in that case, the deviations from normality seems to be a problem. Let us consider an example. So here we got the SPSS file in front of us. I have got a data set in front of me. So we'll try to check the normality of one particular variable. So to conduct a normality test, so we need to go to analysis first, go to descriptive, and go to explore procedure. And once you open the explore procedure, we have to select the variable of your interest, which we need to enter in the relevant field that is in the dependent list. So let us consider the variable of interest. In my case, it is EI, the emotional intelligence. So let me try to shift this variable in the dependent list. Now you go to the statistics tab and click descriptive statistics and click on continue. Then we go to the plot section, remove stem and lead, check histogram, check normality plot with test. Click on continue and make sure that the both should be checked. That is, we want both statistics as well as plots. Click on OK, and once you click on OK, the SPSS will give me the output. So here we have got the output of the SPSS in front of us. So let us discuss them now. So SPSS output shows the skewness and the kurtosis values. If you can check over here, the skewness and kurtosis value. The skewness is the statistics value of the skewness is found to be minus 1.895, and the standard error is found to be 0.088, and for kurtosis it is 5.178, and standard error is found to be 0.176. And if we check on the test of normality, we have to check the Shapiro-Wilks test, and we can see the value is significant. That is, it is less than 0.05. So if you talk about the interpretation of the with reference to the normality, we can say since the p-value is less than 0.05, so we have the null hypothesis is supposed to be rejected. We have to accept the alternate hypothesis, that is the normality does not exist, the data are not normal in our case. So if you want to double check the thing, we can also go for the plots, that is histogram and QQ plot. If you see the histogram, we can see the data is a bit skewed. data is a bit skewed. We can see there are lots of small data which are lying over here. Most of the concentrations of the data are toward this side, so data is a bit skewed data. And also if I talk about the normal PQQ plot, we can see the data are far from this line. Okay, so since this forms a U shape and the shape is moving upward of the line, so we can say this is a negatively skewed data. As we can also check from the output descriptive statistic, we can see the value is minus 1.895, and by looking at this QQ plot also we can interpret that the data is skewed, but it is negatively skewed. So this is how we interpret the normality and we check the normality using SPSS. I hope this video was useful for you. Thank you.